Great, so this one is question 21 on the foundation paper, or it's question 5 on the higher paper. And there's quite a few different areas of maths being involved in this. There's quite a lot going on in this question, but these are the kind of videos if you want to go and have a look at. The 256 and the 255 A1 deal with the conversion that we're going to do in a second, and the 183 and 184 deal with the upper and lower bound stuff that we're going to look at in a second. So it says when Jenna was measured recently, she was 127 centimeters tall. Correct to the nearest centimeter. Now that means that she might not have been bang on 127. It means that she could be anywhere from 126.5 to 127.5 centimeters tall. Okay. For safety reasons, the minimum height for a person to ride the big coaster at a fun fair in the USA is 50 inches. We're told that 20 inches is 50.8 centimeters. Using the information, decide whether it's safe, definitely safe, definitely not safe, or might possibly be safe for her to ride it. So the first thing we need to do is to convert this. Okay, see how many centimeters there is in 50 inches. So if we know that 20 inches is 50.8, we need to get 20 up to 50. Now we can do that by doing another 20 and then a 10. Okay. Notice, like before, I couldn't just add 30 to both here. If you remember that question before when he was talking about taking away 18 and stuff like that, I would have to use this almost the way that you do when you build up percentages, like 10%, 10%, 5%, stuff like that. So I know another 20 inches will be another 50.8 centimeters, and then 10 inches to get us up to 50 would be 25.4. So it would be half of this. So I can add all this up. So 8 add 8 is 16, add 4 is 20, so 0 there, carry the 2. 0 add 0 add 5 add 2 is 7. 5 add 5 is 10, add 2 is 12. So we got 127 centimeters, bang on. So you would be tempted there to say, well, it's definitely safe because that's 127. But this is where we have to pay attention to that. 50 inches is 127 centimeters, but she might not be 127 centimeters. She could be anywhere between 126.5 to 127.5. So you would say it might possibly be safe. Okay? And you might want to just say, right? So part B. State an assumption you have made in your answer to part A, and then part B, comment on the effect that your assumption has had on your decision. These are very, very difficult questions sometimes. What we've been doing all the way through this is you've been thinking and we've been talking mathematically. Stating an assumption a lot of the times requires you to start thinking differently about the question. What assumption have we made within this question that hasn't been stated that means that we can answer it with any kind of sort of certainty? Now the sort of tempting thing to say here is that she is 127 centimeters, but we haven't assumed that because we've said it might possibly be safe. Something else, you could say that the measurement was accurate. Well, we're told that she's been measured and it's it's accurate, correct, in a centimeter, so that's fine as well. We haven't assumed this. We've been told that isn't an assumption. So what we have to think about is she was measured when Jenna was measured recently. Now we don't know what that recently, sorry, I've messed it up there, haven't I? When Jenna was measured recently, we don't know how recently that is, okay? And that's the thing that we need to assume about, that she is still the same height. We can't make any other assumptions there because we haven't been given too much other information. But that's what we need to, that's the assumption there basically, and that is a tricky thing to spot, I think. So the assumption is that her height hasn't changed. Height hasn't changed since she was measured last. And comment on the effect your assumption has had on your decision. Well, if she had changed, then we couldn't. If she'd have grown, she would probably be definitely tall. If she'd grown, she would definitely be tall enough. Because our margin for error there was saying, well, she might be like half a centimetre smaller. So if she'd grown, say, a centimetre, it means that, well, she would have definitely been tall enough. They're difficult questions, those, because they're not particularly mathematical, and they're hard, I think, to summarise and to get down what you mean. We see a lot of this. A lot of people sort of write down something that doesn't actually capture what they want to write down, and that sounds silly, but they're tricky. So you will get more and more used to those as we work through these over the next 12 months. So don't panic too much if this kind of stuff isn't easy at the minute. Okay, right, looking at the mark scheme for this. So part A, 50 inches is 120. So we're getting 2 marks for that. 2 marks for figuring out that 50 inches are 127 centimetres. Okay, so you can see that they've done it the same way that we did. 50.8 plus 50.8 plus 25.4. That would be B1. So that's your method mark effectively for doing that. And then B2 there. And then getting might possibly be safe. Okay. B1, valid assumption. Jenna has not grown, or Jenna is still 127. This one's a bit silly, but is wearing the same shoes. You know, she hasn't got her hair up. You can say things like that, but the assumption has to be based around the fact that her height has not changed between when she was measured and when she's trying to get on this ride in the States. Okay, and then obviously the impact there must be something. Well, if she had grown, she'd definitely be tall enough. Or you could say, well, your answer would be different, wouldn't it? If she's grown, and we based an answer around the fact that she hasn't grown. If she has grown, then our answer isn't valid anymore. Okay, so that's that one done.